Oh, I see.
Yeah.
That makes sense.
Yeah. I was really ready before we had our review then. Because then we started teaching stuff I didn't know. So are we gonna get like a question on our web?
I gave it to you already.
Okay.
Yeah.
Can you speak?
Sure. Let me know. We did. Oh, we did? Yeah. Do their correcting.
Yeah.
Oh, okay, I forgot to.
I mean, we're good for it. I know we talked about it, we've had in your audit, we did already.
Okay.
Like the
Anyone know this one? You heard it? You're welcome.
Because you were thinking of what it's 7 hours. Like always there.
Good morning.
I have a warm up for you. I'm still writing the second question, please. Excuse my tardiness. Sure.
Good memory. That short leg is. I guess the hypothesis is.
Double the short leg and 36.95.
Right, you made it.
Already.
I'm glad you made it.
Please make sure you're checking with your neighbor, make sure that they have the same thing you did. You ready to go over them? Did you check with your neighbor to see if you got the same thing they did? Ivy, you done yet? Just kidding.
Oh.
Some traffic out there. It's my guess. Okay. I want to hear about number one. Good morning, by the way, if I didn't mention it. Sienna, can you help us out with number one, please? Yes, please. Oh, why'd you set it equal to 0? Oh, can't you just like finish it immediately? Or are there more? There's more that you could do. You're doing great, Sienna. Yeah, you're doing great. Yeah, very nice. So you subtract it and you could factor something like this? Okay. Any questions?
Question, is it true that -2 cubed is equal to 8? So what kind of answer is -2? Extraneous, are you okay with that? Not extraneous. That's happening. Not extraneous. Extraneous happens when you do a problem correctly and you can answer it like it worked. It's yes, plus 2x, very common error there. Plus 2x, nice. Right. So you got the same opposite and always plus, but it's like just with plus AB. This will never factor. If it does, you've done something. It's automatic. We're trying to roll back. If this is a factor, what are you supposed to do next? Stop. Are you gonna let a little unfactorization stop you? Not. What do we do? Just check in with your neighbor. What do we do? Okay, so Sienna, I'm gonna give you the first chance to continue from here. What's another option that we do since it can't be that? Okay. So we have x equals 2 and x squared plus 2x plus 4 equals 0. Because of which property do we know this to be true? ZPP, right? Zero product property. I think your book calls it the zero product principle. Either way, ZPP. So you use quadratic formula here. Are we good with that? Either quadratic formula, or since we can't factor, you could also use completeness square. I hope you enjoy completeness square. Those of you who have been attempting it, I do recommend that you keep trying it, but the quadratic formula will always work. Did you finish this problem? Okay, help us out with this. Okay. C equals 4, okay. Nice. Yeah. Should we just stop? It's imaginary, good. Okay, all over 2, right? Okay. Okay. Or should we just stop, or should we do something about it? You could, the question is, okay. Are we good? Yeah, be very careful. That simple looking equation, x cubed equals 8. Obviously, one of them answers is 2, but if that's all you did to get there, you forgotten that there are more solutions to it. Have you seen a problem like this in your homework? I'm sure you have. So the lessons that you learn in your homework, because I know you probably got that wrong the first time in your homework. It's like, what? There's more? You probably had that response. I know I did when I was a student. Right? Who would think that these are solutions? Only a crazy person or a very gifted mathematician. The line between the two is very fine. Did you finish that second question already? I think you did. I like some help from Priscilla for this one.
Well, after this, I did the last one.
Okay.
I just looked aside. Totally bad.
It seems good to me. You raise both sides to 3/2 power. Right. I'm not sure of another way to proceed, honestly. So, yeah, let's keep going.
Positive and negative 1.5.
Why plus or minus?
This is the number.
Oh, okay. I'm sorry, so plus or minus, and I cut you off after that.
5.
Okay,
And that's actually for both sides. So I got actually number 124.
so negative 128 or 122, you said? Are we good with this?
No.
Did you get both solutions? Have you seen a question like this in your homework? Okay. Cool. So it's important that we learn from our mistakes, don't you think? Both mathematically and otherwise. So, I was thinking about last time, and Mia, you missed it. But maybe you heard it on the video. That I was late to class because I made an error. And it just doesn't sit well with me. It doesn't sit well. Not that I was late. I could only blame one person for that. Me. I was late. I goofed and I completely own it. I have no good excuse other than I'm human and I made an error. I feel like the class made an error that may have been worse. What am I talking about? Go ahead and discuss with your partner. What might I be talking about? What am I talking about? Anyone have any idea? I know you have an idea. I know you don't want to say it. I'm disappointed in what I see as a little bit of a character issue. Now, I do understand no one wanted to be the one to come get me. I totally get it. You don't want to be the one. I am concerned that one person did close the door. I'm not asking for names, but I know I left the door open. And someone closed the door, which means to me, now maybe, I don't know, maybe someone else came by and closed it, but it seems to me that you were hiding. Want to make sure that no one saw that there was no teacher, a room full of students with no teacher in here, and then did something about it. Maybe it was an honest error. I don't know. I'm not accusing any one person. I just want to let you know that I'm disappointed that no one came to get me. So if this happens again, and I don't think it will, I'm pretty good about being on time. In fact, I'm usually kind of early, right? I put up a video and everything. Try to make it nice for you to come in. If it happens again, and we're going to be changing seats soon, I'm just going to say it's a responsibility of the person who's closest to the door to come get me. I think that would be easier rather than someone says, I will be the one right? Someone needs to just have that responsibility. So in general, it's the person closest to the door. So Sienna, if you happen to be in that seat next time, it's going to be you. It's probably not going to be you because it's a randomizer that changes everything up. But whoever's closest, Baron's probably, it may be you. I want to keep you in the back. It doesn't make sense to have you in the front. I just feel bad for anyone behind you. So let's just keep that in mind for next time. And also remember that part of the reason you're here is the pursuit of excellence. Pursuit of excellence. Hiding in a room, hoping the teacher doesn't come after 15 minutes. And then you're going to leave. It's not the pursuit of excellence. I'm just saying, it's maybe I have this all wrong. I don't know. Maybe something else was going on. Maybe something else really important. Maybe there was a big Spanish test you all have. You're hoping to get a little time. Maybe that's what it was. You probably had another test that day. You're thinking, I love this class. I love it. But I could really use that time for my other test. Maybe that's what happened. I'm gonna go with that. But your pursuit of excellence just, the focus kind of shifts from time to time. I totally get it. Things that take priority. Sometimes you can't get to homework. Maybe you can't get to a quiz because you have other things. I get it. But just keep in mind that this time is precious that we have together. I hope you're enjoying the class. I do hope you're enjoying it. I want this to be a pleasant experience. I don't want to feel like it's something you're avoiding. Kind of made me feel that. But I also understand that there is a child in you that's becoming an adult. And these are just decisions that you struggle with. And I accept it as part of your growth. So I'm not mad. I'm not going to yell at you. But I'll have this talk with you. And I hope that you hear the message. And it's just not my class. It's every class. Do you hear my message? You hear it, everybody? You hear it? Is it fair? Do you feel bad? Don't feel too bad. If you feel bad, let it go. Learn. Speaking of learning, should I proceed with the curriculum? Oh, and on your quizzes, I looked over them. If you didn't get 100%, I looked over everything that you got wrong, and most people got points back if you haven't seen it yet. So a lot of them came from up to like 66. I thought that was completely unreasonable for most people who got a 66. We came up to like an 85 or something like that. So if you didn't look, make sure to look at some point. I don't necessarily like the idea of giving quizzes online, but it was nice and easy for me, and hopefully it wasn't too unpleasant for you. You want to watch this video again? Not today. We have stuff to do. Great packets. We're going back to this stuff. Functions. Function notation. Cool. So we're going to be talking about properties of functions. Increasing and decreasing and constant functions. One thing I don't like about this arrow right here is that it looks like it's pointing down, and it is pointing down, but graphs are always read from left to right, always read from left to right. So rather than think about that as pointing down, think about it as coming up from kind of infinite in that direction. Because when we're talking about functions, today, we're going to be talking about increasing, decreasing, and constant functions. So like this point right at this point that I've highlighted right here, we could say that the function is increasing or decreasing. If you're reading it correctly, you'll see that pretty obviously that the function right there is increasing, right? Where it's not on a slope that's going down. You're on a roller coaster from this coming from left to right. The function is definitely increasing. So where else is this function increasing? How many points are we? Is it increasing? Infinitely many. So when we're talking about intervals of increase, we're going to talk about x values and put it in what kind of notation? Interval notation. So how can I erase this? There we go. Increase or increasing from, oh, and I have to start with parentheses because I'm going to start from negative infinity, and I can't actually reach negative infinity. If you don't reach it, that's in this parentheses. It increases from negative infinity up to, can you show me the number that you think at which it's gonna stop? It's X values, negative infinity up to -1 is what we're looking for. Does that make sense? That would be for which X value it becomes increasing. Negative infinity up to -1. It's one of the functions makes a description of the X values. Parenthesis or bracket? Well, think about it. Is it increasing when X equals -1? And at -1, it looks like it's at a peak, doesn't it? So it's not actually increasing there. So we're going to put parentheses there. It is increasing just before it, like -1.1. So it's going up to it, but at 1 it stopped increasing. Are there any other intervals of increase here? Go ahead and write the other intervals increase. Make sure that your neighbor got the same thing you did. Show me the two numbers with your two hands. All right, 1 to 2, we're good. Any other intervals of increase? No, that's it. Decrease, go ahead and finish that. And by the way, the person who should come and get me, what a reasonable amount of time to wait before they can get me? How many minutes? Hold up your idea. How many minutes should someone wait before they should come get me? Let's see, 2, 5, 7. I'm gonna say 1. If I'm 1 minute late, please, that's when you come. Because I'm always early. If I'm 1 minute late, that means I'm already 6 minutes late. For my standards, please. Okay, decrease. I'm sorry, go ahead and discuss. I'm gonna call on someone to tell me about where this is decreasing. I think you already know. Okay, well, decreasing, I was gonna call on someone, but show me the first place this is decreasing. Show me from -1 to 1. Yeah, exactly. And really, all you're doing is sweeping your vertical line, that vertical line, that's -1, decreasing, decreasing. -1 to 1. Is that it? Yeah. Also, from 2 to 3, exactly. Constant. Do you see it? Obviously, you see it. It's neither increasing nor decreasing. It's just staying the same from 3 to, is it only to 4, or is it like to infinity? Yeah, there's no indicator that it's going forever. At 4 is a constant. And like, should I put brackets? For both of these, should I put brackets? Honestly, I don't care. It could be either way. You could put brackets or parentheses. Either one is fine. It's a little bit unclear at that point. Is it constant or not? Yeah. Always is a tough answer to give. I'll say almost always. Maybe there's time. Okay, always fine. And if we find another one, I'll take it back. Relative maxima, relative minima. Yeah, it's made up by a person with a computer. It's probably piecewise. It looks like a little bit of a polynomial with linear and constant functions thrown in, but nothing that you need to know. If it looks like that, we have increase, decrease, and constant places. Relative maxima and minima. When you hear the word maxima, that is the plural of maximum. Minima is a plural of minimum. So I think that's right. If anyone here take Latin, is maxima? Yeah, is that right? So maxima is plural. Okay, thank you. So relative just means relative with relation to the area right around it. Like, do you see where the first relative maximum would be? At x equals -1, there is a relative maximum because it's higher than everything is left and right. You know, like even if it went up higher, like this 0.9, always gonna be like immediately left and right is higher than. Oh, I'm comparing them this piece, but I don't care about what's over there. I mean, there. So. Relatives, also sometimes called the local maxima or maximum. Maximum. At -1. Well, actually, let's say it like this. Relative maximum is 2 at -1. And that relative maximum is 2. Where is it -1? There's another one, of course, also at, in this case, at 2. Or at x equals -1, at x equals 2. Maybe that would be more clear. At x equals -1. At x equals 2. Relative minimum. Is what? Yeah, at 1. So the relative minimum would be -2 at x equals 1. Is there another one? We're not going to consider these relative minimum because they have to be lower than the left and right. So it wouldn't make sense. Yeah, but these ones are different calculations. They will say these are all relative maximum. So for our case, let's keep it just simple. Minimum means lower than the things to the left and the right. But how about down here? I don't know what it is. That looks like it's going down forever. So if it's not forever, there's no comparing to left and right. It just goes down forever. There is no relative or local minimum. Cool. Easy. Let's go. Test of symmetry. You all know what symmetry is, don't you? Like we all have this. Our bodies are symmetric where? In general, largely symmetric. Show me. Where are we symmetric? Discuss with your neighbor. Where are we symmetric? It's you have to make a line, don't you? For symmetry. Will you show me the line? That right here. Right, we'd be freaky people if we're like symmetric here, wouldn't we? Like, hello, Mr. Lieberman. Hello, that would cause so many problems. So functions also are symmetric, and there's a line of symmetry, or there's other types of symmetry. Like here, we see that this is symmetric about the y-axis, or with relation to the x-axis, or over the y-axis. I normally say about the y-axis. And notice what's changed in the points. Negative x, comma y. For each point on here, with y values that are the same, there's an x value that is opposite. So x becomes negative x for y symmetry. So of course, this is about the x-axis, And you can see that in the coordinates, y becomes negative y, but the x's stay the same for those two parts of the graph. What kind of symmetry is this called? About the origin, yeah.
Z-axis, yeah. There is a z-axis. But the symmetry that we'll see this year will be different kind of symmetry, not the z-axis, whichever. My y equals. But that's. So about the origin, and that's defined as a rotation of 180 or reflected in the x and then reflected in the y. A rotation probably 100. Yeah, but we're not doing it. It's like a slide until we do more function work. So you can see that here, x and y is being replaced with negative x and negative y. Okay, so it's really easy to see symmetry on the graph. But how about do a function? It's an outbreak, and we have no idea what it looks like. Probably testing out where we can take the problem from. And to go ahead and test for symmetry. So testing for symmetry for the first one, let's see if this is in order x-axis. Is this symmetric with respect to the x-axis? So I'm gonna say axis y becomes negative y. So in my equation, I'm just gonna rewrite it like this. X equals negative y squared minus 1. Let's simplify that. Negative y squared is y squared minus 1. Look where we have ended.
We've ended with the same equation that we started with. When that happens, hey, we started here. Therefore, symmetric with respect to x-axis. So if it gets you back to where you started, then it's symmetric about whatever you're testing. Like when I'm testing if it's symmetric about the y-axis, I'm gonna think about my y-axis and at the x's and negative x's are interchanged. So this becomes negative x equals y squared minus 1. Is there any way to get us back to the original from here? Maybe multiply by -1 or divide by -1? Because it's okay. Therefore, this function for this graph is not symmetric with respect to the y-axis. So don't think you have to graph it or get out Desmos or anything. Can't get back to original.
Therefore, not symmetric. Fine, say not symmetric about the y-axis. That's fine, of course. And we have to do the origin check,
Which means we're going to
Wait, but you wouldn't have to be symmetric about both the x and the y axis, or the origin. But yes, but yes, then both. Well, like here. X and two. We're already done.
So in this case, we get this. By just replacing both of them. We'll simplify a little bit, negative x equals y squared minus y. We're ever gonna get back to the original? No. Not symmetric. With respect to the origin.
X axis. I don't think so. Right. Once you pass the both of them, if they both pass, it's not. I like that about it. Oh, right. It has to be both. And we could see that on the graphic, it has to be suspended. About the X axis and the Y. So. My head, I just have a
Very quick, negative y equals x cubed. No. Y-axis. Y equals negative x, oops, that's not good. Negative x cubed. Does that get us back to the original? No. Origin? Negative y equals negative x cubed. I feel like this one is a maybe. I'm gonna do some work here. I'm actually gonna keep this out of my thought bubble, even though the first two were definitely not. I'm gonna keep this out of the thought bubble. Let's see. Negative x cubed is negative x cubed because 3 is odd. Can we get back to the original? Yeah, multiply or divide by -1, we're left with y equals x cubed. We've just shown that this function, whatever it looks like, is symmetric with respect to the origin, or it has origin symmetry. But neither x, oh yeah, neither x nor y, that's interesting.
Yes, I guess if both of these are yes, then you can say origin. What if both of them are?
Looks like, oosh, oosh. Like that. Not respect symmetric with respect to the x-axis or the y-axis. And we'll be doing that function sooner than later. Even in odd functions, just like numbers are classified into even and odd. If a number isn't even or odd, you know what it is? It's just neither even nor odd. There's no other classification. Zero an even number or an odd number? Is it either one of those? Is it more even than odd? Do we agree? Or is it strictly even without any sort of question? Definition of an even number is a multiple of 2. Is 0 a multiple of 2? It's not.
multiple of 2. So like when you put in 1 on 2, obviously 0 is not a multiple of 2. Very definitely. Okay, I'm gonna start with symmetries, even functions and those symmetries. These are always symmetric about y-axis.
Listen. Odd functions. Always symmetric. About. Could a function be symmetric about the x-axis? Let's take a look here. Something up here is symmetric about the x-axis. Is that a function? Discuss with your neighbor. What's a function? Dylan, is it a function? Why not? What about the vertical line text? Yes, what does it do to the vertical line text? Pass or it fails the vertical line text, doesn't it? It fails the vertical line text. Yeah, no function matches much. Impossible. The only thing that's left for odd functions is like it's symmetric with respect to the origin.
Wait, so what was the one that we did earlier?
Oh, it's just not, if this is a function of y, which we're not going to be dealing with. We're doing functions back for each input, there's one output, and our input is always going to be the horizontal axis. In this class, until you get to Calc BC, then they'll play with it a little bit more. Okay, so here, going back to this, odd functions and the symmetry, always symmetric about the origin. So very easy to recognize. So I'm going to draw a sample graph here that is symmetric about the, or with respect to the y-axis. Can you visualize a graph that is symmetric with respect to the y-axis? A really simple one. Something that you already know. Maybe a parabola. Was anyone thinking that? If not, that's fine. Does it sound familiar? Parabolas? The U-shaped graph? Oh. I could do it. I can draw a good. Oh, there we go. That's nice. And symmetric about the origin. I can do one that's similar. The one I just did. It goes up on this side. Let me make it a little bit better. Up on this side. Down on this side. So I'm going to mark here negative x and positive x. Same thing here, negative x and positive x as I switch to the definition of symmetry. What's that? Non-functions. Okay, so for even. For even functions, f of negative x is equal to negative x compared to f of x. So they're saying f of negative x equals f of x. By definition. Anytime I'm asking you to show me that a function is even on a test or a quiz, that's what you need to start with. For odd functions, f of negative x is equal to. What's happening in this sample graph? The y values are opposite, aren't they? You know that's the word opposite in math. Negative. So opposite of f of x. Have you heard that? Negative is opposite. Like, and think about it, just -3. Isn't that the opposite of 3? On the number line, 3, -3, the opposite. And so negative is just another way to say opposite. So by definition, if you're trying to prove that something is odd, you're gonna show me that f of negative x equals negative f of x, or the opposite of f of x. A, B, and C. Okay, I'll give you a chance to discuss with your neighbor. Okay, so of course, A on the count of three, 1, 2, 3. It's odd, we know because it's symmetric about the origins. We see that 180-degree rotation.
Exactly.
Odd. And if you see a graph, I would expect you to not do the test of f of negative x, just see that it's symmetric with respect to the origin. B on the count of three, 1, 2, 3. Even. Because it's symmetric about to the y-axis. I don't need you to show me the algebraic reason. C, is it odd or even? No, it's neither one. Just like numbers, if it's not even or odd, it's just neither one. So this
What
is
number is that?
yeah, what number is not even or odd? Oh yeah, good question. Is there a number that's not even or odd? Check with your neighbor.
Well.
So if you'd like to tell us what number is neither odd nor even. What is it? No clue? Okay, we'll discuss it at 8:50. I have to have a chance to meditate and zone out. If you need to stretch, now's a good time. 50. Let's say 51. There's enough time. In the meantime, I'll play a little Bee Gees because the song's amazing. So 70s. One of the best pop love ballads of all time, right here. Enjoy it.
Like, a reason to be.
I'm on break now. I'm grooming the Bee Gees. You never heard this? No? Oh, gorgeous. Australian band. Early days of video, about as cheesy as you can get. By music video, of course. Okay. Stop. I know you want to hear the rest. I know you want to hear it, but we got to get back to reality. Okay. Identifying even or odd functions from equations. I already mentioned that right here. That's exactly what it is. That's the good stuff. Even remember that with respect to the y-axis, when it makes sense if that x is negative. Whether it's x is going to be negative x is going back. So odd is placing in the negative x and you get a negative y is that. Oh, so a non-even or non-odd number, you mentioned 3.2. Is that even or odd? Is it a multiple of anything? 2? It's neither. It has to be a natural number. And it has to be an integer. It ends with an even digit. It's not even. Not odd. You think of another number that's neither even nor odd? Hopefully you just thought of a billion of them at once, didn't you? Anything that's not an integer is going to be neither even nor odd. Okay, let's move on. You guys seem sleepy. Is it like a Monday? It's Monday-ish today. Maybe that's what's going on. Okay, so I'm going to check to see if this is even or odd. So all I have to do is plug in negative x. Let's see what happens. This is negative x cubed. What happens to that? Minus 6 times negative x becomes plus 6x. Now we're not back at the original function, but look what happens. If I factor out a -1, I'm left with x cubed minus 6x. And x cubed minus 6x is our original function. So f of negative x equals the opposite of f of x. Algebraically, we just found that the function is odd. Therefore, odd. Therefore, f of x is an odd function. What's that? Well, f of negative x is negative. You have to find out that the back. It is odd. Isn't that strange? Happened in second time? No. It'll get funny. It'll get there. Let's check. G of negative x is where we begin. Negative x to the fourth minus 2 times negative x squared. We simplify. As you simplify it, you see the first term becomes x to the fourth. The second term becomes. Oh, should I do something like make this plus? Anything like that? No. Have that. Do it. X on the square is negative x squared becomes x squared, leaving us with negative 2x squared, and we notice they are the same. So what we were left with, g of negative x is equal to g of x. Therefore, we have an even function. So if you were to look at the graph, this would be symmetric, about to be, can you show me symmetric about even means symmetric about the y-axis? The first one was symmetric. Show me the first one, symmetric. The first one was odd, so symmetric. Show me that kind of symmetry. The origin. Well, imagine you're poking the origin. Okay, let's move on. Any questions? H of negative x. Dun, 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 dun. Did you get what I did? So is it symmetric with respect to the y-axis? Is it even? Is it odd? It's so close to even. It's going to be like plus. It'd be a bit. Two things factor out a negative one, is any factor? No. Therefore, the function is either odd or even. So h of negative x does not equal h of x, and it does not equal h of negative x. Therefore, neither odd nor even. Yes, you could just write neither. Yes, yeah. Yeah, I'm just trying to do all of it. Stop breaking. Yeah. And stop right here and just say you. Oh, thank you. It's definitely equal to h of negative x. It is h of negative, but it's not equal to negative h of x. Thank you for thinking of this critically and not just blindly writing it down. That was nice. Oh no. Oh no. Oh no. Let's look at the silver line. You have time for homework. Okay, okay. Okay, highlight of your day, math homework. Good job to those of you who got hundreds on the quiz, by the way. A couple of them. A couple of you got hundreds. For those of you who didn't, next time. Put on BGs. No, you're working. You shouldn't be distracted.
How much is it like this?